Okay, so we're going to go through our Python assignment to get some feedback on what we have done so far. So your assignment was to do a rock, paper, scissors game where two players present a choice of the three objects and a decision is taken of who won by the rules. By now you are conversant with the rules. We've done this a number of times. Your assignment was to code this game. All right, submission, we all did that. Now grading will go like this. You get a 2 if your code actually runs. Get a 2 if your code is correct. You get a 3 if your code is complete, meaning that it's an actual game, it actually works. You get 3 points as usual if I'm impressed. And for copying, -3, which I realized so many people got -3. Now, some feedback. First of all, always write your index number in your documents. Some of you upload documents without your index number in the actual document itself. So I see a PDF or a Word file. It just has code in it, and your index number is not written in it. I'm not going to go out of my way to search and see who it corresponds to. So make sure you always write every detail in your document. And please, as much as possible, upload PDFs. All right, PDFs were made for a reason. When you try to upload other file types, sometimes there are a few of you that your files were corrupted. So what I got is content I cannot read. So that is why we use PDFs. So to convert your writing, whatever you write it, save it as a PDF and upload it. All right, that is the best way to send documents. All right, now first feedback, don't forget input. I came across a few codes where the code itself would have been good if there had been input, but most likely you went somewhere, you studied it online, you copied it online, and you didn't go through the code to remember that you need input. If there's no input, that code will not run. All right, you learned this already. In programming, there is input, there is output before every other thing. So if you don't have input, that means that the code is useless. So never forget your input. All right, and then be careful of your syntaxes. I noticed that a lot of you are not testing your code. You are simply writing and submitting them without ever running them. All right, and we have no excuse because we can all find a way of testing it. You are all supposed to install your applications. So test your codes. If you have the chance to test your code, you test it. All right. I will only be lenient in, let's say, an exam where I know you don't have a compiler. But when it's an assignment, your code, the code that should arrive should run. If it doesn't run already, you lose a lot of your marks. All right. So for example, print into bracket start. This doesn't really mean anything. This would only mean something if start is a variable you've already assigned somewhere. But I've seen this a lot. Some of you typed this, and those of you who copied from those who typed this copied the mistake over. All right, you can't type print start, and start is not a variable. Start has no meaning, and there are no inverted commas. All right, this will do absolutely nothing. More problems with your cases. Be careful about the cases. None of these is correct. Right? You do not type a print with a capital P or elif or if or while or else. All those things are lowercase. So if you had this in your code, it means it will not run. All right. Again, if you didn't test your code, that's the only reason why you would make this mistake. A simple test would have shown you that there's a problem with writing it with a capital. So please make sure you test any code that you are given, you are submitting before you submit it. And remember, in programming, cases are important. It's not just these particular ones. It is cases of almost everything, variables. You can't have a variable with a capital somewhere and later on change that capital into a small letter. All right, you have learned this. You even know the technical reasons why they are not the same. All right, so remember that when you are doing the actual work. So, for example, variables. Again, with a capital A is not the same as again with a small a. All right. So I came across this where you are using again somewhere with the capital, then suddenly you change it to a small letter, it will not run. All right. And again, if you test your code, you will find out that there's a problem. All right. And then this example, this is an example of bad coding. You do not put, first of all, this code is not user friendly. Right, remember that somebody is going to play this game. So you type print rock, paper, scissors, then you type print shoot. So what is going to appear is rock, paper, scissors, shoot. I don't know if that will make sense to anyone, right? And then you put input, but your input has no prompt. So it will just print the first line, print the second line, and then it stops. And the person is not sure whether the person is supposed to put something inside where it has stopped, or is supposed to just wait for it. All right, make sure that your code is user friendly. It should say something like input rock, paper, or scissors. It should give the user a prompt. All right, otherwise, if the games we have been playing online or on our phones were written this badly, we wouldn't like them. All right, so as you code, remember that your code must be user friendly. Think of the person who will actually use the code and what they will see. Right. Again, the problem here is testing. If you had run this code and tested it, you would have realized yourself that it's a bit inconvenient to use, and you would have fixed it. Right. So test the code. All right, then those are the bad ones. Let's go to the positive side. I met some impressive coding. For example, and I've taught you this, that anytime you're asked to coding, there are 1,000 ways of doing it. So this one example where someone didn't bother using um, if the normal if statements that I showed you to check if rock is equals to paper, or if this, what the person simply did here is make a function which does one of the variables minus the other one and finds a difference. All right, so okay, I didn't put the whole code, but at a place he assigns numbers to those variables. So rock is, let's say, 0, paper is 1, another one is 2, and then he actually uses mathematics to check the differences. And with this, he's able to calculate the whole thing with just one line. Right, so this is an example of thinking a bit deeper and doing it more efficiently. Another example of impressive coding is this, right? This person simply compared the two variables. So if variable 1 and variable 2, this will actually compare the two. If they are the same, it will say true. If they are not the same, it will say false, all right? So this is another more effective way of achieving what we're trying to do without a lot of code. Again, this one too, another example of impressive coding, because this code is documented very well. Every single line is explained. There is nothing that is not explained as to what the line is doing. Right? And the advantage with this is if another code programmer takes this, I can easily understand what is going on. I can easily modify, I can easily add something, change something. All right. So every single line, and in fact, for a code like this, even if there is a mistake in it, because it is so well documented, it will be very easy for me to fix, because I know what the person is trying to attempt, even if they don't get it. So document your code. Make sure that every line you are saying what is happening. The reason why most of you did not come up with this is that in practice, you tend to forget all what you learned. You were supposed to write pseudocode, and you were supposed to do an algorithm, and based on that, you're supposed to do your coding. If you had done that, then automatically you would have documentation, right? But because you are copying, or you are simply trying to do it without thinking, that is why you don't have good documentation, right? So the people who, see that these are their codes should know that they've immediately gotten very high marks, probably all the marks in this assignment, because that is very good work. All right. So please go through this feedback and make sure that you understand the feedback you have gotten. Look at your code again. Look at the feedback that I've mentioned and make sure that you understand it in context of your code. All right. So see you in the next lecture.